Hey guys, so this is the Are You Ready assignment for math this week. We are moving on past chapter 2 on to chapter 3. Chapter 1 and chapter 2 were both review chapters from 4th and 5th grade. So this is now officially 6th grade. So the Are You Ready page is just getting you ready. Are you prepared to start learning 6th grade materials? If not, what are your misconceptions or misunderstandings? And this page is going to help me as your teacher figure out what it is you do and don't remember or what you have not learned before. So, this is an explanation. We're going to go over this during our live meet. However, if you missed that or you don't have time to tune in, this is what this video is. It's going to be the same thing I do in our live meet. So, write each improper fraction as a mixed number. So we have an example up above, and I know it's a little blurry when we zoom in. You should have picked up your textbook. You can do the page in the actual textbook. This is if you don't have a book and your app isn't working. Alright, so I'm going to click the plus sign in drawing so I can write. Now, Miss Wernicke does have a stylus, and that does help her write. I suggest getting one if you don't have one. Alright, so for example, 11 over 3 equals 3 over 3 plus 3 over 3 plus 3 over 3 plus 2 over 3. Okay, so we have the numerator over the denominator. So the numerator is the number on top, if it will let me write. I need to buy a new stylus. I've been using this one every day. Numerator over denominator. And that's basically the part over the whole. So the number on the bottom or the denominator equals the whole. So we have 11 over 3. So if you have 3 over 3, that's one whole. So you can see here we have 1, 2, 3 wholes. That's where they got the 1, 1, and 1. When a number is over itself, it is one whole. It doesn't matter if it's 15 over 15. If the number on the top and the bottom are the same number, it is one whole. So we have 3 wholes and a 2/3. So they changed the mixed number from 11/3 to 3 2/3. So if the number is bigger in the numerator, if it's a larger number than the denominator, it's going to be called an improper fraction. So when we come down here to 1, 2, 3, and 4, write each improper fraction as a mixed number. So we have the numerator is 7 and the denominator is 2. So 2 over 2 equals 1 whole. So how many wholes fit into 7 halves? Well, 7 minus 2 would be 5. So we took out 1 whole. So I'm just going to put a 1 underneath it. And then we're left with 5 halves. So if we take out 2 more, we have a whole and we're left with 3 halves. I know I'm writing this backwards on this keynote, but during our Google Meet, I will be sure and not do this. However, I'm just making this very quickly, so please be understanding. So 3 over 2 still leaves us another whole, so we take out a whole another whole, and 3 minus 2 is 1 half. So now we have 3 wholes and 1 half. So 1 plus 1 plus 1 is 3, and we have a remainder of 1 half. So if you got 3 and 1 half without even thinking about it, you are definitely ready for 6th grade math. However, if you didn't get that right away, don't stress out. That is why we are teaching it to you. Okay. So what I like to do in my head is kind of like think of the whole or the improper fractions as how many times can it fit. And I know that sounds a little weird right now, but like, for example, 12 fifths, sorry. 12 is in the numerator, 12 is above the 5. So when we change our improper fraction to a mixed number, we're going to get a whole number and then a fraction, and your fraction is going to have the same denominator always. So that 5 can just be moved over. How many times does 5 fit into 12 evenly? 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15. So 15 is too big, so it fits in twice evenly. So I know my whole number is going to be 2. 5 times 2 is 10, 12 minus 10 is 2, so I have 2 remainders. So if you're confused on how I did that, you can just count how many whole numbers go into 12. So 5 plus another 5 is 10. So I got 2 wholes from there. Another 5 would be 15, but we don't have 15 in our numerator. We only have 12. So I have 2 wholes and then 2/5 remaining. So now number 3, I have 11/7. Okay, this one's a little bit easier because 7 is our denominator. I'm sorry, I'm struggling today. 7 times 1 is 7, and 7 times 2 is 14. So 2 wholes will not fit because 14 is larger than 11. So we only have 1 whole. So now we just do what's remaining. After you take 7 whole out, what's remaining in your 11? So you just do 11 minus 7, which is 4. 1 4/7. Now we have 4/15. Okay, so I want to remind you, 4/4 equals 1 whole, all right? So if I have 4/4 and I take out 15/4 minus 4/4 equals 11/4. So we just took out 1 whole right there, so I'm just going to draw a 1 on top. Can I take out 4 more? Let's try. 11 minus 4 is 7. So I have another hole right there. Now let me try taking out another 4/4. 7 minus 4 is 3/4. So yes. So I have 1, 2, 3 holes, and I have a 3/4 down here. It might be hard to see. But I have 3 holes, and then what's remaining is 3/4. So I'm going to erase all my work so you can see my answer. 3 3/4 is the answer. Now, what I want you to think about, as a 6th grade student, you are like, you might be a little confused. You might be like, this is really new for me. This is the first new material you should be seeing. The rest of it should have just been kind of review. So when you see 3 3/4, I want you to, in your brain, always remember that when you converted this number here, 15/4, to this number, you didn't take any away and you didn't add any. So they are equal numbers. An improper fraction turned into a mixed number is the same exact number, okay? So if I had 3 3/4, that's like having 3 whole pizzas and then having 3/4 of a pizza. So then we just pretend that somebody ate 1/4 of our pizza, okay? So that's what having 15/4 is. So if I split all of my pizzas into fourths and I counted up all of my pieces, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's where it came from. There are 15 pieces, all right? So the number on top is the part, and the number on bottom is the whole. So when you see I have 4 pieces in this circle, that's the whole circle. That's a whole number right there. So 15/4 means there's 15 parts, okay? And every 4 parts is 1 whole. That might still be confusing, but hopefully I have helped you out a little bit. Hopefully that makes some sense. Now we're going to do it backwards. Write each mixed number as an improper fraction. I like this better because it's pretty straightforward. You do. All right, you do the whole number. Let me change to the marker. Whole number times denominator. Wow, I spelled that really wrong. Plus numerator. And then that answer goes on top of the original denominator. That's going to make a little more sense in just a second. Sorry, my handwriting sucks. I do apologize. Denominator. The stylus, I need a new one. Alright, so if I have 2 1/2 and we want to change this mixed number into an improper fraction, that is where we make it a larger number over a smaller number. So you take your big whole number 2 times your denominator 2. 2 times 2, that's easy. That equals 4. Then we add our numerator. What's 4 plus 1? It's 5. So 5 is our new numerator, and our denominator is always going to stay the original denominator. So if you look in the original problem, 2 is the original denominator. So 5 halves. Now number 6, our whole number is 4. So we do 4 times our denominator, which is 5, which equals 4 times 5 equals 20. And then we add our numerator, which is 3. So now we have 23 on top, and my original denominator goes on the bottom. My original denominator is 5. So to me, this one is much easier. I think it's less thinking. You just do the math. So now I have a whole number of 3, and my denominator is 9. 3 times 9 equals 27. Then you add your numerator. 27 plus 4, 31. Wow, that looks awful. Let me try that again. 31 over my original denominator of 9. Then number 8, 2 and 5/7. I do 2 times 7 equals 14 plus 5 equals 19. Then I put it over my original denominator. You can do a little slash if you don't have enough space. I like to do that a lot. And then down here, 9, 10, 11. Whoops. That is comparing decimals. And this should be kind of review. It's place value mostly. All right. So we have 8 and 86 hundredths compared to 8 and 65 hundredths. Okay? So you just look at our place value. They both go to the hundredths. So we look 5 and 6. Then we look at 6 and 8. You basically only need to look at the tenths place. The tenths place is the first spot behind the decimal. 8 and 86 hundredths or 8 and 65 hundredths. If it goes to 2 decimal places, you can think of it like money. That's like $8.86 or $8.65. You obviously want $8.86, so it's greater. Now down here we have to 3 decimal points. So we have 0.732 and 0.75. So our ones place are both 0. Our tens place are both 7s. Okay, so far right there they're equal. But then here's where it gets tricky. Our hundredths place is 3 and our hundredths place is 5. So right there, that 5 determined it. 0.75 is larger than 0.732. Now our next one, this one is one kids always get wrong just because they're not paying close attention because they want to get their homework done. We have to look at our ones place. They're both zeros. Now we look at our tenths place. One's a 2 and one's a 0. 2 is greater than 0. You already know. However, kids will say, well, this has 3 numbers behind. Doesn't matter. If they both have the same ones place, then you go to the next place, the tenths. And then if they both have the same ones, you go to the hundredths. Whoever has the largest would be the greatest. So 0.22 is greater than 0.022. Now order 0.98, 0.27, and 0.34 from greatest to least. So that's the biggest to the smallest. So we can think of this as money. 98 cents, 27 cents, and 34 cents. So the biggest one is going to be 98 cents, so 0.98. Now we have to determine is 0.27 or 0.34 larger. The 0.34 is. It's like having 34 cents. And then the smallest one is 0.27. So that is just the get to know you, like, are you ready page. If that was really, really hard for you, don't worry. You're going to be learning more and more and more about this week, next week, and the week after. I hope this helped.